Hey, in this tutorial we're looking at section 10.4, which is on applications of probability. Okay, so there's not a lot of theory in this section. There's very little, in fact. So I've just fleshed it out a little bit more. Okay, so one of our things that we'll get to a little bit later on, I think in a little bit more detail, is about our 68, 95 and 99.7 rules. They only really talk about the 95% rule in this section, but I want to add in the others because it makes sense to now anyway. So basically we say that the probability that x is between one standard deviation below the mean and one standard deviation above the mean is equal to 0.68. Okay, so remember our mu is our mean and sigma is our standard deviation. So this is our mean minus our standard deviation and our mean plus our standard deviation. Okay, similarly, our probability that x is between two standard deviations below the mean and two standard deviations above the mean is equal to 0.95. And the probability that that x is between three standard deviations below the mean and three standard deviations above the mean is 0.997, sorry. Okay, so there's not any more theory to go through, just a couple of worked examples that we'll get stuck into now. So worked example 8, okay, we're saying that we've got y is a discrete random variable with the following probability distribution table, which we have here. So y can have the values of 0, 1, 2, 3 and 4, and the probability of each of those occurring is also down there. Okay, so what we need to do is we need to find the expected value of y first. Okay, so remember our expected value of y, okay, we simply multiply our y values by the probability of our y values and add them together. So our e of y is simply 0 times 0.08 plus 1 times 0.34 plus 2 times 0.38 plus 3 times 0.17 plus 4 times 0.03. Okay, and when we do that, okay, and do the arithmetic, we find that our expected value of y is equal to 1.73. Okay, for part B we need to find the standard deviation. Okay, well, in order to find our standard deviation, we first need to find our variance. Okay, so remembering that our variance might come up over here. Our variance of, y in this case, okay, is equal to e of y squared minus e of y squared. Okay, well, we already know what e of y is, we've just worked it out. Okay, what we need to do is work out our e of y squared. So this time, okay, our e of y squared, we square our y values before we multiply them by the associated probabilities. So we say then that we've got 0 squared times 0.08 plus 1 squared times 0.34 plus 2 squared times 0.38 plus 3 squared times 0.17 plus 4 squared times 0.03. And when we do our arithmetic for that, we find that we get 3.87. Okay, so that means then our variance in x is equal to our 3.87 minus our expected value of y squared. So minus 1.73 squared. Okay, when we do that, we get a variance of 0.8771. Okay, so now that we've got our variance, we can find our standard deviation. Because remember, our standard deviation, sorry, that should be y, okay, is equal to the square root of our variance. Okay, which means our standard deviation is the square root of 0.8771. Okay, which means we get a standard deviation of 0.9365. Okay, which is part B taken care of. Part C, we're asked to find the probability that y is between our two standard deviations here. Okay, now we're not just allowed to use this rule, okay, because we don't have a normal distribution. Okay, but you'll find that our answer will actually be quite close to that anyway. So we need to say then that we'll go work out mu minus 2 times our standard deviation. Now remember, our mean is our expected value. Okay, so that means this one is going to be 1.73 minus 2 times our 0.9365, okay, which gives us negative 0.143. And our mu plus 2 standard deviations, that's going to be 1.73 plus 2 times 0.9365. Okay, so that means that we're going to get a value of 3.603. Okay, so we want the probability, okay, that we are between minus 0.143 less than or equal to y, it's less than or equal to 3.603. Now if we have a look though, okay, we've got a discrete probability. Okay, we've got a discrete probability. So we can't actually take these values here, okay, because they're not actually associated values. So we've got to be between negative 0.134, where our lowest value is actually 0. So I'll just come up here. That means that we're going to be looking at the probability of being 0 is less than or equal to y. Now we can't be 3.603 either, okay, but because we're a discrete probability, that means we don't round up to 4, we actually need to stop at 3. So when we do that, then we're saying, well, this is equal to our 0.8 plus our 0.34 plus our 0.38 plus our 0.17, and when we do that, we find that we get a probability of 0.97. You'll see that's actually quite close to our 0.95. Okay, so remember, these rules do work, okay, but only for when we've got a normal distribution, which we talk a lot about normal distributions a bit later on. Okay, at the moment, okay, they're only approximations. Okay, so we've got one more worked example we'll have a look at. Okay, so this time we're talking about a biased die has a probability distribution for the outcome of the die being rolled as follows, which we've got here. Okay, we need to find the probability of getting an even number. Okay, the probability that x is greater than 3 given that x is less than 5. Okay, and then we've got to find the probability that we're within 2 standard deviations. So to look at the probability of an even number, okay, so say A, B and C. So for A, probability of an even number is really going to be a probability of 2, 4 or 6. Okay, that means that we're going to be 0.1 plus 0.25 plus 0.1. Okay, so we're simply going to be 0.45. Now for part B, okay, we might need to be thinking back a little bit here to our given probabilities, okay, which we studied in more detail last year. Okay, so saying that we've got the probability of x is greater than 3 given that x is less than 5, well, what that means is we've got to be probability that x is greater than 3, okay, intersection x is less than or equal to 5 divided by the probability that x is less than or equal to 5. That's the way our rule works for our given questions. Okay, so the probability that we are greater than 3 and less than 5, well really we can write that a different way and say really that that's going to be the probability that x is between 3 and 5. Okay, because the intersection between being bigger than 3 and less than 5, well that's just between 3 and 5. Okay, so that bit is going to be our 0.2 plus 0.25 plus 0.25, which is going to equal 0.7. Okay, now we also need to look at our probability, okay, that x is less than or equal to 5. Okay, well you can think of that too as well. It's going to be equal to 1 minus the probability of being greater than 5, or 1 minus the probability of 6. So it's 1 minus 0.1, so that's going to equal 0.9. So looking at our equation now, we can put it all together. Okay, and say our probability that x is greater than 3 intersection x is less than 5 is our 0.7. Okay, over our probability of being less than 5 is 0.9. So I'm going to say that is 7 over 9. Okay, and we're done for that part. Okay, in part C, we've got to find the probability that we're within 2 standard deviations. That means we've got to actually find our different values. So, for part C, that means we need e of x. Okay, and remember that's our 1 times our 0.1, 2 times 0.1, etc. 1 times 0.1 plus 2 times 0.1 plus 3 times 0.2 plus 4 times 0.25 plus 5 times our 0.25 plus our 6 times 0.1. Okay, when we do that, we find that we get 3.75. Okay, so that's our expected value which we need. Okay, we also need e of x squared. Okay, so this time we're going to be our 1 squared times 0.1 plus 2 squared times 0.1 plus 3 squared times 0.2 plus 4 squared times 0.25 plus 5 squared times 0.25 plus 6 squared times 0.1. So that gives us a value of 16.15. Okay, so then we need our variance, okay, which is our e of x squared minus our e of x squared. Okay, so that means we've got 16.15 minus 3.75, sorry, 3.75 squared. Okay, when we do that, we get the variance of 2.0875, which means our standard deviation is the square root of that, 0.0875, which gives a standard deviation of 1.4448. Okay, so now we can look at our mu minus our 2 sigma. So that's our expected value, 3.75 minus 2 times 1.4448, okay, which is going to equal 0.8604. And look at our mu plus 2 sigma, which is our 3.75 plus 2 times 1.4448, okay, which is going to give us 6.6396. Okay, so we want to know what the probability is that we are between 0.8604, okay, it's less than or equal to x, it's less than or equal to our 6.6396, okay, which is equal to the probability. Well, when we have a look, our lowest value is 1, less than or equal to x is less than or equal to, well, hang on, our highest value is 6 and we want above that, so we'll go be less than 6. But we know that then, when we look at all of these probabilities, well, that has to equal 1. Okay, so in this case, all of our values were within 2 standard deviations of the mean. Okay, when we look back here, okay, well, our rule was 0.95, so pretty close to 1 anyway, but again, these rules are only really for normal distributions, which we're not having right now. Okay? So they're only an approximation. So it's not too bad. You just really need to set up your work pretty clearly when we're looking at this in terms of finding your mean, finding your e of x squared, finding your variance, finding your standard deviation. Really follow through and do that nice and clearly so that you can then build up your equation and sub in the values as needed. If you're doing that, then you really won't have too much trouble with these questions.